morning, students. This is the lecture number 33 on the sequencing and scheduling topic, and we are going to study the third case in this topic, where we are going to learn the processing of two jobs on M machines. So, the processing of two jobs through M machines is done as follows. We are assuming that the jobs are numbered as 1 and 2, and there are M machines, let us say A1, A2, AM, and the technological ordering of each of the two jobs is known in advance. Now, what is the technological order? It means that the first job has to be done and then the second job has to be done. Such ordering need not be the same for both the jobs. Exact or expected processing times, that is A11, A21, A31, etc., and similarly AM1, A12, A22, A32 and AM2 are known. So, the times which are required are known. This is given in the problem. Now, the problem turns out to be to minimize the total elapsed time denoted by capital T. And now, as you know, the definition of the total elapsed time says the total time from the start of the first job to the completion of the last job. Now, for solving these kind of problems, we have the graphical method, where we are going to solve this particular case. Now, the example that we are going to use to understand this method is as follows. Use the graphical method to minimize the time needed to process the following two jobs on the machines A, B, C, D and E, for which the data is given in the following table for each machine. Find the job which should be done first and also calculate the total time needed to complete both the jobs. Now, this means that we are given the following information. So, there are two jobs, job 1 and job 2, and the time required in hours is given. So, also the sequence of the times is also given, that is, first A has to be done and the time required is 2, then B time required 3, then C then time required 4, D time required 6, E time required 2. Now, this is for the job 1, and the job 2 says that first C should be done, that is, it will take 4 hours, and then A it will require 5 hours, D it will require 3 hours, E it will require 2 hours, and then B it will require 6 hours. So, the technological order is given. On the job 1 has to be processed first on A, then on B, then on C, and then on D, and then on E, whereas the job 2 has to be processed in this sequence C, A, D, E and B. Now, how to solve this particular case? This is solved with the help of this graph. Now, we have to understand what is being represented here. Now, on the x axis we have the job 1, it is the x axis, the horizontal axis is showing the job 1, and on the vertical axis is showing the job 2. As you know, there are only two jobs, job 1 and job 2. Now, since the job 1 has this, the first one is A. Look at the table again, look at the table again. A requires 2 hours. Okay. So, therefore, this distance is 2. A is requiring 2. Then comes B. So, what is B? B requires 3 hours. So, how I am going to mark it? 2 plus 3 is 5. So, this is B, right, because it requires 3. So, 2 plus 3 is 5. Then comes the third one, that is C. So, C requires 4 hours. So, from 5 units we have to add 4. So, 5 plus 4 is equal to 9. So, this means this is C, right. Then again the fourth one is D. It requires 6 hours. So, from 9 plus 6 is 15 and this is D. And finally, the last one E. It requires 2 hours. Therefore, this is 15 plus 2 is 17. So, here is our E. This is our E, right. So, I hope everybody has followed how this demarcation has been done on the x axis, that is corresponding to this sequence A, B, C, D and E. This is the technological order of performing the job 1. This has been marked on the x axis like this. So, first we have A, then we have B, then we have C and then D and then E. Next we have to do the same thing for the job number 2, but the technological order is different. Here the technological order is first you have to do C, then you have to do A and then D and then E and then B. So, we have to follow this technological order. Also we note that C requires 4 hours. So, therefore, what we need to do? First of all, from 0 we need 4 hours for doing the C job. Look at the table. First we have to do C and C requires 4 hours. Therefore, this demarcation is shown here, that is C. Next comes the A and A requires 5 hours. So, therefore, from 4 to 4 plus 5 is 9. So, this is our A. Then comes D. D requires 3 hours. So, therefore, 9 plus 3 is 12 and this is D. And the fourth one is E. It requires 2 hours. So, therefore, 12 plus 2 is 14. So, this one is E. Then in the end we have B, which requires 6 hours. So, from 14 plus 6 is 20 and this is B. So, once you have done the demarcation on the y axis and on the x axis, next comes the construction of the rectangles, which is shown here in the shaded region. So, since this one is A and this one is A, so therefore, we have to do the pairing and construct the rectangle like this. As you can see, this is A. Then comes B. B on the x axis is here and on the y axis is here. So, the rectangle that has to be constructed is this one. This is B. Third is the C. So, here is C on the x axis and here is C on the y axis. So, the rectangle that is obtained is this one. Then comes D. This is the rectangle corresponding to D, and finally, the rectangle corresponding to E. So, this is the way we have constructed the rectangles. Before we proceed further, let us just look at the steps that have been written in the next slide. Let the processing times of jobs 1 and 2 be represented along the x axis and the y axis respectively. This is, I have already explained this. What is the meaning of the processing times? How the processing times have to be plotted on the x axis and on the y axis corresponding to job 1 and job 2. Second step says, mark out the machine times for the two jobs on the corresponding axis in the given technological order. Now, remember that the technological order for job 1 is different and the technological order for the job 2 is different. Step 3 is construct the blocks as shown in the shaded rectangles starting from the origin by pairing the same machines until the finish point is reached. So, you can just look at it, this is the finished point. We have to complete all the pairing and then construct the rectangles. Step number 4 says, now start from the origin O and draw lines which pass through the states of completion points of various jobs until the point marked finish is obtained. Now, this has to be understood carefully. We will now determine the optimum path. We have to determine the optimal path starting from the origin to the finish. And how do we have to do this? We have to construct a line in such a way that the 45 degrees angle is made over here, okay, and keep on moving like this until you hit across a particular rectangle. Now, we have hit across this rectangle, the one given by B, and this means that now we have to decide whether we have to go in the horizontal direction like this or we have to go on the vertical direction. Now, here this decision will depend upon which is the smallest. So, in this case we find that the vertical distance is the smallest, right, and therefore, we move this line in the vertical direction and come to the corner of this rectangle. And once we reach this corner, then again we move at a 45 degrees and proceed like this to the finish. This is outlined in the step number next. Moving to the right means that job 1 is processing while job 2 is idle. If you move to the right, then this means job 1 is processing, okay, and if you move up, that means job 2 is processing. So, we have to if we are moving upward, then it means job 2 is processing, and if we are moving towards the right, then it means job 1 is processing. Also, when job 1 is processing, then job 2 is idle, and when job 2 is processing, then job 1 is idle. Also, moving diagonally means that both the jobs are processing simultaneously. So, see, the objective is to minimize the elapsed time. Therefore, it is important that we should make the diagonal movements as much as is possible. So, both the jobs cannot be processed simultaneously on the same machine. Obviously, it is understood that both the jobs cannot be processed simultaneously on both the machines. Graphically, this is ensured when the diagonal movements are done through the blocked out shaded region. This is not allowed. So, when you come across for example this point, you cannot move in this diagonal direction, this is not allowed. Therefore, you have to either move in the horizontal direction or in the vertical direction. Now, to find the optimum path, an optimal path or a program is the one which minimizes the idle time for job 1, that is the vertical movement, as well as idle time for job 2, that is the horizontal movement. And thus, we have to choose a path such that on which the diagonal movement is as maximum as possible. Now, to find the elapsed time, we have to look at the elapsed time is obtained by adding the idle time for either of the jobs to the processing time for that job. So, what is the elapsed time for job 1? It is the processing time for job 1 plus idle time for job 1, and the processing time of job 1 is 17 hours and the idle time for job 1 is 3 hours. Let us just verify this. See, this is the 17, this is the processing time, and the idle time is this distance, this one, 3 hours. So, therefore, 17 plus 3 is 20 hours. And similarly, for the job 2, the elapsed time is processing time of job 2 plus idle time of job 2. Now, the processing time of job 2 is 20, but there is no idle time for 2. So, therefore, the total time is 20. With that, we come to an end of this case of the sequencing and scheduling. Thank you.
Ma'am, this is 17 minutes, ma'am.
Okay, I will give the closing once again.
Okay. Ready, ma'am? Ready, start.
So, this means that we have the elapsed time for job 1 and the elapsed time of job 2 as 20 hours and 20 hours for job 1 and 20 hours for job 2. Now, if you look at the graph, just look at this graph, this is what we have. We have the finish, this finish is at 17 hours over here and 20 hours over here. Understand the reason why we are using a diagonal movement for finding out the optimum path. Why we are using the diagonal movement? The reason is that we want that job 1 and job 2 should be processed simultaneously as much as possible, because if job 1 is processing and job 2 is not processing, or in other words, if job 1 is processing and job 2 is idle, we do not want that. So, this sort of a situation should not arise. I mean, this should be as minimum as possible. So, let me again, horizontal lines or horizontal movement implies like this, that we are moving in the x axis direction, and vertical movement implies y axis. Okay. So, since the diagonal means both jobs are being processed, So, this diagonal movement should be as maximum as possible, because this will mean that the idle time are minimized for both the job 1 and job 2, and that is the reason why we are encouraging more and more diagonal movement. So, therefore, the final answer says that our elapsed time for job 1 is 20 hours and the job 2 is 20 hours. These kind of application problems arise in the industries where there are, let us say, a number of machines and there are, let us say, 2 jobs, and you have to determine the optimum path which should be adopted, so that both the jobs can be run on all the machines that are available and the elapsed time is minimum. With that, we come to an end of this case. Thank you.